Hi, my name is Jessica John Britta. My roll number is 20PH214 and I'm on section 20. For the DIY group project, I have made a line follower board. And the components that I have used for making this robot are one Arduino Uno, two DC motors, each of 6 volts, 200 RPM, and two ultrasonic sensors, two IR sensors, two batteries, two breadboard, and one motor driver. The Arduino Uno can provide a maximum of 200 milliamperes of current, which is sufficient enough to power the sensors, but not sufficient enough to power the DC motors. So as to power the DC motors, I have used two batteries, each of 9 volts. Both of them are connected in series that would give a total power supply of 18 volts to the DC motors. And here is the pin configuration sheet of the ultrasonic sensor, and I followed this while making connections of the ultrasonic sensor to the breadboard in the Arduino Uno. And here is the pin configuration sheet of the IR sensor. And before, I was not aware of the usage of the potentiometer of the IR sensor. So upon Googling and watching few YouTube videos, I understood the usage of potentiometer of this IR sensor. The trip pod is used for tuning the sensitivity of the IR sensor. In my case, I have tuned it in such a way that the obstacle LED of the IR sensor glows when it's on the white region and it does not glow when it's on the black region.
The main issue I faced while fixing the IR sensor to the Arduino Uno board and the breadboard is mainly because of these defective jumper wires. Initially, when I was connecting the IR sensor using these wires, the power LED of the IR sensor did not emit any light, which meant the IR sensor was not receiving any power. So I assumed that the IR sensor was not working, but then when I tried to power the IR sensor directly with the 9-volt battery, the IR sensor started to glow. So which made me to check the connectivity of these 6 faulty jumper wires, which I was initially using for connecting the IR sensors. So now I have set this to the connectivity test over here, and if the ends of the jumper wires are connected, then it will give out a beep sound. So since it's not connected, we are not getting any beep sound from the multimeter, but because those are the faulty ones, and this one is not a faulty one, and hence we get a beep sound, which means it's the ends of the jumper wires are connected. The main issue I faced while fixing the IR sensor to the...
Here is the pin configuration sheet for the L293D motor driver, and I'll be explaining usage of each of these 16 pins using this site, which I myself used while teaching myself to make the connections of the motor driver to the DC motors on the Tinkercad. So pin 4, 5, 13, 12, 8 and 16 are the power supply pins of the L293D. Pin 4, pin 5, pins 13 and 12 are the ground pins, so they are grounded. And VCC2, which is the 8 pin, is used for powering the DC motors. So I connected this directly to the positive terminal of the battery, of the 18-volt battery, and the 16 pin, which is the VCC1, is used for driving the internal logic circuit, and I connected this directly to the 5-volt pin of the Arduino Uno board. The output terminals, pins 3 and 6, I have used these two pins for the left motor, pins 14 and 11 for the right motor. The control pins. Pins 2 and 7 are the direction control pins of the left motor in my case, and pins 15 and 10 are the direction control pins for the right motor. And this chart was quite useful while I was writing the function for move forward, turn right, turn left, stop. And I used the same logic while writing those 4 functions. And pins 1 and 9 are the speed control pins. Pin 1 is for the left motor and pin 9 is for the right motor. But I have not used this, and I've set the speed of the motors to either low or high. So I have not used the speed control pins in the code. And here is a circuit diagram for the connection for L293D and the DC motors, and this I had used for reference. And also this site by Adafruit was quite useful while I was learning to understand the connection while I was learning to understand the interface, how I could interface the DC motors and the L293D. So this was quite useful. Here is a code for the line follower robot. I have used variables IN1 and IN2 to control the direction of the left motor and have set them to 9th and 10th digital pins of the Arduino Uno board. And I've used variables IN4 and IN3 to control the direction of the right motor and have set them to 6th and 5th digital pins of the Arduino Uno board. In variables IRL and IRR are used for reading the data from the digital pin of the IR sensors on the left and the right respectively, and I've set them to 13th and 12th digital pins of the Arduino Uno board respectively. Initially, I've set all the direction pins of both the motors to high state, and I've set IRL and IRR to input state. And here is the line follower function code. Variable S stores the digital value read from the IR sensor on the left, and variable K stores the digital value read from the IR sensor on the right. So if both the sensors are on the black region, that means they are on the black color line, they both will read a digital value of 1. So in that case, the board has to move forward. And so I've called the forward function. And if the left sensor is on the white region and the right sensor is in the black region, the board has to take a turn so as to align itself back on the track. And if the left sensor is on the black region and the right sensor is on the white region, in that case the board has to take a turn towards left so as to align itself back on the track. And I have called the line follower function in the void loop, and I've given a delay of 250 milliseconds for optimization. And here is a function stop. So I have set all the directional pins of both motors to low state, although I could set them to either high or low, but I've set them all to low in my case. In forward function, I have set IN1 to high and IN2 to low. So this will make the left motor to spin in the clockwise direction, and IN3 to high and IN4 to low. This will make the right motor to spin in the clockwise direction, and hence both the motors will move in the forward direction, and so will the board. In turn right function, I've set in1 to high and in2 to low, so the left motor will spin in the clockwise direction, and I've set in3 to low and in4 to high. This will make the right motor spin in the anti-clockwise direction. So since both the motors are spinning in opposite direction and the left one is moving in the spinning in the clockwise direction, the right one is spinning in the anti-clockwise direction, this will make the board take a turn towards right. In turn left function, I have set in1 to low, in2 to high. So this will make the left motor to spin in the anti-clockwise direction. And I've set in3 and in4 to high and low respectively. In this case, the right motor will spin in the clockwise direction. So this will make the robot to take a turn towards left. Here's a code for the obstacle avoidance robot. Previously in the video of the line follow robot, I had explained the pins for the left and the right motors along with its motor driver, and the variable L sonar trick is used for the trigger pin of the left ultrasonic sensor and have assigned to 7th digital pin. And L sonar echo is for the echo pin of the left ultrasonic sensor and have assigned to 4. And the R sonar trick is for the trigger pin of the right ultrasonic sensor and have assigned to 3. And R sonar echo is for the echo pin of the right ultrasonic sensor and have assigned to 2. And the variable CM stores the front distance between the bot and the obstacle on its left, and CM1 stores the front distance between the bot and the obstacle on its right. So here's the function, read ultrasonic distance. This function is used for calculating the time taken by the ultrasonic sound wave to travel back to the sensor upon encountering an obstacle. So initially, we had proposed to make a line follower and an obstacle avoidance robot for the DIY project, but for which I had made an integrated circuit that is including the function line follower as well as the obstacle avoidance function, and I had integrated in such a way that they were executed uh, with a specified condition. So that was it. So after making this program, I did the test running on the robot, but unfortunately the bot did not follow the path that I expected it would, the path which I expected it would from the predictor from the code that I had written for it. So to debug it, to know where I was going wrong, and to rectify it, I decided to make them separately, that is to debug them separately. So since I wanted to test the obstacle avoidance robot code, I have commented out this line follower function as of now. And also the issue that I had faced with making the integrated circuit was that the bot was not following the line follower function at all, although when it was in the black color line. So upon encountering, it just followed the obstacle avoidance code, although it did not follow it completely, but it was good enough to avoid a good number of obstacles that I had put up on its path. But it never followed the line follower code when I had made an integrated program consisting of both the functions. So to debug it, I had started with the obstacle avoidance. So time variable stores the time taken by the ultrasonic sound wave to travel back to the ultrasonic sensor upon encountering the obstacle, and cm stores the distance, and I have used the formula vt upon 2, and I've made the conversion to centimeter, so the distance is stored in centimeters. So as I had stated, that initially we had proposed to make a line follower and an obstacle avoidance code, so for which I had created a circular or an ellipsoidal loop for the bot. That is, I had created a black color track for it. So if the distance between the obstacle and the bot is greater than 30 centimeters, then the bot has to follow the line follower code. And if it's less than or equal to 30 centimeters, then it has to follow the obstacle avoidance code, which I'll be explaining in a bit. So the logic behind the line follower and the obstacle avoidance robot is that, supposing if the distance between the obstacle and the bot is greater than 30 centimeters, the bot is safe to move on the black color region and until it encounters an obstacle at a distance less than or equal to 30 centimeters. Upon encountering this, it has to follow the obstacle avoidance code mentioned in the if loop, and finally it will come back to its track after following the obstacle avoidance code. So since I'm just testing the obstacle avoidance code, I have commented out the line follower function and I've replaced with a forward function. So I have used the forward function because if there is no obstacle, if the bot does not encounter any obstacle on the path it's traveling, it is safe to move on the path. That means it can continue moving on the path. So that's why I've used this function. So in case it encounters an obstacle less than or equal to 30 centimeters, um, then it stops for a second and then it calls upon the check area function. So in the check area function, um, I've also given the time delay for each turn. For each turn the bot makes. So um, it immediately takes a turn right for the specified milliseconds. In this case, it's 3 seconds, and then it stops and then calculates the distance between the obstacles and the between the obstacle and the bot um, in that area. So if there is no obstacle encountered, then it returns 1. Else, if it encounters an obstacle, then it goes on inside this loop and follows this code. So after encountering the obstacle, again in that area, it will take a turn left for 3 seconds and then stops and then again calculates the distance between the obstacle and the bot. And if it does not encounter any obstacle this time, then it returns 2. Else, it takes a turn right and then calls upon the check area function with increase in delay time while taking a turn. So why this check area function has been called again? The reason is because after this, um, this will increase the this will increase the area the bot is able to scan and find a path which does not have an obstacle at a distance less than or equal to 30 centimeters. And then it will take on that path uh, and use that path to avoid the obstacle it has encountered in the beginning. So that's why this check area is given with much delay, because the delay, if the delay time is increased, it will be able to turn more and it can cover the area it did not cover previously. So that's why I have done this. So if k is equals to 1, then the bot executes the await right function, else it executes the await left. So await right function is actually when the bot encounters an obstacle on its right. So in the await right function, it moves forward, then takes turn left, then forward, then left, and then forward, and finally it's back on its track. And the await left function is used when the obstacle encounters and when the bot encounters an obstacle on its left side. So in this function, it moves forward, then takes a turn right, then forward, then a right, then forward. So this is about the obstacle avoidance code, and in the next video I will show the demonstration of the obstacle avoidance bot. As you could see in this video, the bot is unable to identify the first obstacle and it goes right past into it and follows its course. And also from the demonstrations, I realized that the bot is not able to sense all kinds of obstacles, especially the ones with lesser density and also which are below the IR sensor, which means which are out of the range of the IR sensor, and also denser obstacles such as the tapes are not sensed or not detected by the bot. And the bot is also quite good at detecting the walls. And also it cannot detect dynamic obstacles. It can detect dynamic obstacles, but that will lead to erratic results, which you'll be seeing it towards the end of the video. So, as you must have seen in the previous videos, I had shown a demonstration of the obstacle avoidance bot. So, after a good number of demonstrations and a good number of rectifying the mistakes in my code, I finally arrived at this present code that I'm displaying now. Although it's more or less the same, I've added more print statements to know exactly where I'm going wrong and whether the bot is able to execute or follow each and every line of the code that I've written here. So upon doing the test running of this code on the bot, I happened to arrive at this. So as you could see here, currently the second last statement it has printed is the second right, which is this statement right after the turn right function. The serial monitor has displayed the second right. So after the second right, uh, the data that should be displayed on the serial monitor is the delayed time. But unfortunately, it did not print it. Rather, it printed 10 right, which is no way to be seen in the subsequent print statements. So at this point, I did not understand where I was going wrong, and it was becoming hard for me to debug it even more. So I decided to Google up to check the potential uh, ways where on the serial monitor we would be getting a garbage value printed. Uh, so um, so upon Googling, I did not find quite fruitful answers regarding this issue, but I happened to come across answers from Stack Exchange that in which people stated that using AVR programming or AVR Studio is way better than Arduino IDE because in that we could um, pinpoint each register because a register, and hence we would be able to debug the program more efficiently. So that was it. So this is all about the presentation. So although I could not complete this project, this was a great learning experience for me. I had learned a lot in lot about the robotics basics. Although I won't say that I've learned all of it, but I've got a good exposure to robotics. So thank you for investing your time into watching this video. Hope you have enjoyed. Thank you.